In this video, we're going to export contours from a high-resolution digital elevation model and simplify those contours. This is the digital elevation model. It's about 3 meters per pixel or so, and you can see the resolution is pretty high. So right from the start, we know that we're going to have to simplify those contours because they will probably have a lot of points on them, so they will be difficult or impossible to work with in other applications. Now I dragged and dropped the digital elevation model in QGIS. The first thing to notice is that my project coordinate system here in the bottom right corner is set to 3857, which is a projected coordinate system. We do not want to work in geographic coordinate systems. So this is the one I used. And if we hover over the digital elevation model, we can see that it's using EPSG 4326, which is a geographic coordinate system. So if we go under properties and information and scroll down, we can see it right here. It says geographic, which is a problem because if we export the contours from this, then those contours will be using degrees and we won't be able to simplify them. So we want to convert this file, first of all, to projected coordinate system so that we can use metric units to do our work. And another thing is that there's this black banding around the digital elevation model. We want to get rid of that because it distorts the elevation banding. You can see it starts from minus 32,000. So we will begin with that. And the first thing you can do is to click on the Identify Features command here, or press Ctrl Shift and I. Then click on the black banding. This will open this panel, and all we're interested in is this value, which is the same one that we have here, but we can just copy it from here just by right-clicking on it and choose to copy attribute value. Then we can immediately convert this file to a projected coordinate system. And whenever you're doing this, it may be a good idea to put a Google Satellite overlay behind the DEM just so you know that everything is projected where it should be. So we can go under Web, Quick Map Services, and this is a plugin you have to install if you do not have it. And then go under Search QMS. And in the search field type Google and then choose one of the satellite maps here and add it. So now it's in the background and this project is in Georgia. And then we can reproject this. So go in the bottom left corner in the search field, type project, and then you can find this algorithm called warp reproject. So double click on that. Under input layer, we will have the digital elevation model. Under source CRS, we will specify the coordinate system that the layer currently has, which is 4326. If you don't see it here in the list, just click on the globe button and search for it in the search engine there. Then for target, we know that we want 3857. So we can select it either from the list or again click on the globe button. Resampling method will be staying the same. And under no data value is where we're going to paste the value that we copied earlier, which is this minus 32,767. And then click on Run. This will both reproject the digital elevation model and get rid of the the black elevation banding. Then we can close out of this and turn off the visibility of the original layer, and everything is reprojected where it should be, and it aligns well with the original layer, so there are no issues there. And now we can extract the contours. So we want several extractions. So we want one for 5 meters, 2 meters, there's also 3 meters and 1 meter. So we can begin with the highest one always, just so that we don't run into any issues. So we go under extraction, under raster menu, extraction, contour. Then we select the reprojected DEM, and for interval between contours, we start with the 5 meter. Everything else here can stay at default, and then we can click on run. So that's not too bad. It's fast enough. So you see the contours were extracted. We can just quickly right click on this layer and go under rename. And I'm just going to set this to 5. Go under parameters and switch this to 3 now and extract those. And then also rename these to 3. Now we're going to the 2 meter. Also rename these to 2, and finally the 1 meter. So all of the contours were extracted. We can close out of this algorithm and also select all of our previous layers and delete them. We don't need those. And now everything is named. So we can start with one at a time, starting with the highest one. We will use the generalizer plugin. For me, this is located here. For you, it may be somewhere in the dashboard here at the top. Just open that up. For input line layer, we're going to have the 5 meter, and we're going to start removing first the small objects. So leave the algorithm at remove small objects. I like to start with a value of around 65 or so, and press OK on that. This may take a while, especially once you start going into the lower contour spacings, so you may have to wait. Now let's just quickly compare to see if this removed anything. Actually, nothing was, there were some, so you can see the small ones were removed. And that's okay, we are going to have a lot more of this noise on the lower spacings, so we can leave that and delete the original one. If for some reason these contours did not appear here in the view panel, then that's because the plugin reprojected them to a different coordinate system. All you have to do is right click, go under layer CRS, and just assign the 3857 projection that we chose. So again, we're going to run the generalizer plugin on the same layer that we just created, called _memory. And we're going to go under simplifying, and now you can choose a value here that you want. I like to start with something like 0.5 meters for these higher contour spacings, because there's not that many contours. But when we go down to the lower ones, we are going to increase this threshold maybe to 1 meter or even more, just because we have a lot more contours. So we want to simplify them even more so that they're still easy to load in other applications. So I'm gonna start with 0.5 meters on this and press OK. This simplifying process may take the longest because it's the most processing intense. So you may have to wait quite a while, especially once you get to the 2 meter or 1 meter contours. So the contours were simplified, and now it's good to always zoom in and see what has happened, see if it removed too many points. So the green is what we got and the red was what we had before. And you can see that there's not a lot of deviation from what we had in the past, but it did remove some points. And what you can also do is quickly export these contours out just to test how quickly they export and what the size of that export is. So without even renaming it or anything, I'm just going to go under export, save features as. We're going to export this as a shapefile. So let's choose Esri shapefile under format, and then click on the ellipsis button. Give it a name like contours. So I'm going to call this contours-5 and press save. then uncheck Add Save File to Map and press OK. If they export very quickly, then that's a really good sign. Then you can also go in the folder and inspect the size of these contours. Now they're a little bit on the high side. It's 8.6 megabytes. So what you may want to do is go back, delete these contours that were just created, go back under the generalizer plugin, select the contours again, go under simplifying again, and maybe increase this to 1 meter. Because again, you want to simplify them just as much as possible, but not too much to compromise the integrity of the accuracy of the contours. But then again, we also want them to be usable in other applications, so the less the file size is, the better that is. So these contours were also exported or processed rather. Now again, we can examine them. You can see it did not deviate too much from the original. So that's good. And now we can export them again to verify. I'm gonna first delete the previous contours we exported. And then right click on the new ones, save features, and quickly export them to the same place. Now you can see we managed to shave off a megabyte or two. So that's good. I don't think we can do any better without compromising the contour accuracy further, so we can leave them as they are. Now I'm going to delete the previous contour layer and just rename this one to contours-5 meters. We can also go under the symbology for this and just change the color to something like black or any other color that you want. We're not going to do any indexing on this one, just a simple color. And that's it for this one. So the process for the other ones is basically the same. I'm not going to cover it, but you just go under the generalizer plugin, remove the small objects, and simplify to the degree that you're satisfied. You may have to do a higher value for these contours because they have tighter spacing. And then you just set a color that you want and you export them. Now the color does not matter if you're exporting to shapefile because shapefile cannot retain the symbology of a layer. But if you are exporting to, let's say, KML, what you can do is go here under symbology export and set this to feature symbology. This is going to retain the color that you have set on the contours. But again, on shapefile, it does not matter. So we do not have any options for doing that. And so once you've simplified the contours, then just click again here on the ellipsis button and export them. Just make sure that you name them each one correctly so that you can then differentiate which files belong to which contours. And that's about it. So I'm gonna process the rest of these contours and export them and then upload this video. So thanks for watching and see you in the next video.